how MOSFETs work. Now we are studying the NMOS MOSFET. So first you know the device structure. That is, this is filled with a p-type substrate, and these are two side n-type substrates. The source, drain, and the gate. This is the silicon dioxide layer which covers both the source and the drain, that is insulator between the substrate and the metal above it. So then how does it work? We first see how it operates with no gate voltage. When there is no gate voltage, it just performs like two PN junction diodes. Now how to create a channel flow? We first apply a VGS voltage, that is, so what we do is we apply a VGS. So there's a positive here, there's a positive here, so all the positive charges here are repelled and they go downwards, and this has more holes, and both the electrons from these two, from the source and the drain, that is both the end substrates, come towards this. So there are this channel of electrons created here, and therefore a channel is created. The more the VGS, the more the density of the electrons over there. So but for the channel to be created, a minimum VGS is required, and which is called the threshold voltage, and so now we see what happens when we apply a small VDS. When we apply a small VDS, there's a positive here, negative here. So electrons move from the source to the drain, therefore the current is in this direction, that is ID is in this direction, and this can only happen if VGS is sufficient and the channel is created. And the density of the electron, the magnitude of the current depends on the density of the electrons, the density of the electrons depends upon VGS, and the more the VGS is above VT, the more ID, as we can clearly see in this graph, that as the ID is more, if the difference between VGS and VT is more, ID is more, and obviously ID increases with increase in VDS.